Hi, this is Mrs. Doris with Lesson 2-5, Literal Equations and Formulas. Our objective in this lesson is that you will be able to rewrite and use literal equations and formulas. And again, this is important because equations can be used to solve real-life problems. One of our vocabulary terms in this chapter is a relatively new one. That vocabulary term is literal equation. A literal equation is simply an equation that has two or more variables in it. So in problem 1, we're going to rewrite a literal equation. You will find this very, very useful as we proceed through algebra this year. Okay, in the first problem it says solve the equation for m. So we're going to look at m as our variable, and we're going to isolate the m on one side of this equation. I'm going to rewrite the equation so it's a little bit more here in the center where we can work with both sides. All right, if I want to solve for m, again I ask myself what happens to m? Well, we first multiplied it by 2, and then we subtracted 5n. So to undo what has been done to the m, we're going to work backwards. And first of all, we're going to undo subtracting 5m, which means that we're going to add 5m. All right, so or 5n. Let me erase that. We're going to add 5n. So let's add 5n to both sides. All right. On the left-hand side, since 5n and 4 are not like terms, I'm just going to write it like this, 5n plus 4, or I could have written 4 plus 5n, either way. On the right-hand side, minus 5n and plus 5n is equal to 0. So I'm left with 2m. Next, I have to undo the multiplication by 2. So I'm going to divide by 2. Always remember when you are showing division, we're not going to use the division symbol. We're going to show it as a fraction. And also I need to do the same to the left-hand side. Notice that I have to divide the whole left side by the 2. All right, so let's see what we end up with. 2m divided by 2 is simply 1m. All right, and I'm going to move it over to the left. And then on the other side, I have 5n plus 4 over 2. So let's rewrite that separately. We have 5n over 2 plus 4 over 2. All right, we can simplify 4 over 2 so that we have m equals 5n over 2, sorry, I'm running out of room here, plus 2. All right, so there I have solved the equation, and I'm going to rewrite it down here a little bigger so we can see it better. 5n over 2 plus 2. All right, now the next question says, what are the values of m when n is equal to -2, 0, and 2? All right, this is why we solved for m. It makes it much easier to substitute numbers in for n. So, first of all, we're going to take -2. Substituting -2 in for n, I have 5 times -2, all divided by 2, plus 2. 5 times -2 is -10. So I have -10 divided by 2 plus 2. Negative 10 divided by 2 is negative 5, and negative 5 plus 2 gives me negative 3. So when n is negative 2, I get m equal to negative 3. All right, let's now take the same equation, m equals 5n over 2 plus 2, and this time we're going to substitute in the 0. All right, substituting in 0 for n, and I'm going to run out of room. I'm going to take a shortcut here. 5 times 0 is 0. 0 divided by 2 is 0. So I have 0 plus 2, which is equal to 2. Okay, so when n is equal to 0, m is equal to 2. All right, now let's take our last value. Suppose n equals 2. All right, so I'm going to go ahead, take my equation where I've solved for m, and I'm going to substitute 2n where I see the n. All right, going ahead and multiplying 5 times 2 is 10. 10 divided by 2 is 5, and 5 plus 2 is equal to 7. So when n is equal to 2, m is equal to 7. Problem 2, rewriting a literal equation when we only have variables. What equation do you get when you solve negative t equals r plus p times x for x? All right, in this case, we want to solve for the x. So asking ourselves what was done to the x on the right-hand side, first we multiplied the x by p. Oh, I don't want to use an x and a p together. I'll show multiplying this way. So times p. And then we added on an r. So once again, we're going to work backwards and undo these steps. First of all, we want to undo the plus r, so we're going to subtract r from both sides. All right, r minus r is equal to 0. On the left-hand side, I have negative t minus r. On the right-hand side, all I have left is px. All right, next we want to undo the multiplication by p, so we're going to divide by p. And of course, using algebra, we're going to show our division by drawing a line under each side, and we're going to divide both sides by p. On the right-hand side, p over p is equal to 1, and 1 times x is equal to x. And on the right-hand side, I have negative t minus r all divided by p. And that's my answer, solving for x. While this may look like Greek at first, when you get used to it, it's really very easy because you're not actually having to do some multiplication or addition or subtraction. Problem 3, rewriting a geometric formula. What is the height of a triangle that has an area of 24 square inches and a base with a length of 8 inches? All right, well, let's first of all talk about the formula for a triangle, for the area. Area for a triangle is equal to 1/2 times the base times the height. All right, so the question is, what is the height? Now, in keeping with this idea of solving for a particular variable, we're going to do that first, and then we'll answer this question. Solving for the height. And the nice part about doing that then is you can change the area, you can change the base, and it makes your computation much easier and quicker if we have already solved for the height. All right, so first thing I want to do if I'm going to solve for the height, which is this variable right here, is to get rid of the 1/2 b. I'm going to deal with the fraction first. In order to get rid of 1/2, I'm going to multiply it by its reciprocal. So I'm going to multiply both sides by 2 so that I can get rid of the 1/2. 2 times 1/2 is equal to 1. So what I have left is 2a is equal to b times h. Now I need to undo the multiplication of b times h, and since I'm solving for the height, I'm going to divide by b. All right? b over b is equal to 1, and 1 times h is equal to h. On the left-hand side, I have 2 times the area divided by the base. And that is now my new formula. I can find the height of any triangle given the area and given the base. So in our example, I'm going to rewrite my formula up here. 2 times area over the base is equal to the height. All right, my area is 24 inches, so I'm going to take 2 times 24. In my formula, my base is 8 inches, so I'm going to divide by 8, and that should give me my height. All right, moving down here, 2 times 24 is 48, divided by 8, which is equal to 6, and that is my height. Let's see, let me go ahead and write it this way. And that, therefore, I can label my height is 6 inches. Problem 4, rewriting a formula. Pacific gray whales migrate annually from the waters near Alaska to the waters near Baja California, Mexico, and back. The whales travel a distance of about 5,000 miles each way at an average rate of 91 miles per day. About how many days does it take the whales to migrate one way? All right, the formula that we're going to use is the distance formula. The distance formula is distance equals the rate of speed times the time. In this case, and substituting in what we know, we want to find out how many days that it's going to take. Days would represent the time, which is our t. So we're going to take our formula and solve it for t. What I see is that I have the r that I have to get rid of on that side if I solve for t. So to undo the multiplication, I'm going to divide both sides by r. R divided by r is equal to 1. 1 times t is equal to t. And on the other side of the equation, I have distance divided by rate. All right, substituting in what we know, we have a distance of about 5,000 miles. So substituting 5,000 in for the distance. The rate of speed is 91 miles per day. So we're going to divide by 91. And that will give us our t. All right, dividing 5,000 by 91, we get 54.945, et cetera, et cetera, et cetera. Keeps going. So since the question says about how many days, we're going to round this off and we'll say that the number of days is approximately 9 would round up, so 55 days is how long it will take the whales to migrate from Alaska to Mexico. All right, I want to do a few more literal equations. If you are taking your notes on the handout, you will find that these are not there. But because we will do this so much during Algebra 1, I want to do a few more. So I would recommend on the back of your notes adding these examples. All right, in each of these literal equations, we are going to solve for y, because that's what you'll be doing a great deal of in upcoming chapters. All of these equations are what we call the standard form of a linear equation. These equations are much easier to graph later on if we put them in what we call slope-intercept form. And to be in slope-intercept form, we have to isolate the y. What you're going to do first is move the x term to the other side of the equation. The x term can only be moved by adding it or subtracting it. So since we have a positive 2x in this equation, we're going to subtract 2x from both sides. All right, on the left-hand side, 2x minus 2x is 0. 0 plus 3y gives me 3y. On the other side, we have 6 minus 2x. Now, I'm going to reorder these. I'm going to put my x term first, which would be the minus 2x, and then, because 6 is positive, it'll be plus 6. Please get into the habit of putting the x term first on the right-hand side, and this will put it then in the slope-intercept form that we will be working with a lot. Okay. Now I've got to undo my multiplication by 3, so I'm going to divide everything by 3. 3y divided by 3 is 1y. On the other side, I have negative 2/3 x. Notice that negative 2x over 3 is the same as negative 2/3 times x. Plus 6 divided by 3 is 2. So here is my equation that I have rewritten. I have solved for y, and now it is in slope-intercept form. And we'll explain more about that in upcoming chapters. Let's do another one. 3x minus 4y equals 12. Again, first thing that you want to do is subtract 3x from both sides. 3x minus 3x is 0. 0 minus 4y is negative 4y. Please note, this sign is very, very important, and it must be brought down and become negative 4y. On the other hand side, putting my minus 3x first, 12 is positive, so I'm going to put plus 12. Now we're going to isolate y by undoing the multiplication by negative 4, and we're going to divide all of our terms by negative 4. Negative 4y divided by negative 4 is a positive y, 1y. And on the other side, negative 3x divided by negative 4. Negative divided by negative is positive, so I'm going to rewrite this, 3/4 x. 12 divided by negative 4 is negative 3. So I can add negative 3, which is the same as subtracting 3. In my next equation, again, I want to move the 4x to the other side, and the only way that I can do this is to take 4x minus 4x, which is 0. Again, I've got 0 minus 5y, which is simply negative 5y. On the right side, I have negative 4x minus 20 because it was a negative 20. All right, let's divide all of our terms by negative 5 to undo that multiplication. Okay, negative 5y divided by negative 5 is a positive 1y. On the right side, negative 4x divided by negative 5. A negative divided by negative is positive, so I have 4/5 x. And minus 20 divided by negative 5 is positive 4. All right, one more. This time I have negative 7x plus 2y equals negative 14. First thing I do, as I've done in the others, is to move the x term to the other side. Now in this example, my coefficient is negative 7, so I have to add the opposite, which would be a positive 7x to both sides. Negative 7x plus 7x is 0. 0 plus 2y is 2y. And on the other side, I'm going to put my x term first. Since it's a plus 7x, 7x is positive. And then because 14 is negative, it's minus 14. Divide both sides by 2. 2y divided by 2 is a positive 1y. 7x over 2 is 7 over 2 times x. And minus 14 divided by 2 becomes minus 7. If you have any questions, please don't hesitate to ask. I will be happy to show one in class with a little bit more detail, which may be helpful to you. So please ask any questions that you have. This is really not very difficult. It's basically a two-step type of a process, but it can look a little confusing at first. Once you practice it some, then you'll be very confident with it. Thank you very much.